Welcome back. Let's discuss graphs of motion. Vertical projectile motion may be described through graphs. Like we have this graph here, which is showing us a relationship between two quantities, which is the displacement or position versus time. Right, we're going to discuss these graphs. We're going to look at the position versus time graph, velocity time graph, the acceleration time graph. But on this tutorial, I'm just introducing the position versus time graph. But again, we're going to look at these graphs in detail in the next tutorial. This one is just like an introduction to the position versus time graph. The position versus time graph indicates the position or displacement of an object at different times during its motion. At any instant, we can find the displacement. At any particular time, we can read the displacement. So the position or displacement versus time graph indicates position or displacement of an object at different times during its motion. It is parabolic in shape, so it can be either concave up, depending on which direction you choose as positive, or it can be concave down. Right, this one is concave down, this one is concave up. You see that? Depending on which direction you choose as positive. The zero position, what is it? This is the starting position of the object. It's not like on the ground every time. It can be on the top of the building. Remember, the projectile can be launched from the top of the building, can be launched from the ground, can be launched from a balloon, like something like that. So that starting point is what we call the zero position. If the graph moves away from the reference point, from zero position, displacement of the object increases. Right? As the object moves away, displacement increases. Like let's say this is the displacement at this particular time, let's say t1, at t2 the displacement is here, so it means it has increased. As the object moves away from the reference point, displacement of the object increases. If the graph moves closer to the reference point, displacement of the object decreases. Right, let's say now it is at its maximum point, then it's starting to move towards the zero position. What is happening to displacement? Let's say this is displacement at t1 is there, and then at t2 is now there. See that? So as the object moves towards the reference point or the zero position, displacement is decreasing. Please take note of that. Then let's just talk about the gradient. The gradient of the tangent to the graph at any point gives the instantaneous velocity. The gradient of the position time graph will give you velocity. Please take note of that. At any particular time, right? Let's say at this time, at t1 here, what is the gradient here? The gradient will what? Will give you your velocity, right? Check what is happening here, right? As you start from the initial velocity, the gradient is very steep, isn't it? And then the steepness reduces, meaning that the velocity is what? Is decreasing as you move upwards. Remember, acceleration is downwards. So as you move upwards, the gradient decreases, meaning that velocity decreases. It decreases till it gets to zero at the maximum point. And then after that, it starts going down. Now what is happening to the gradient now? It's even becoming steeper. Okay, you see that? It's becoming steeper, but it's becoming steeper in the opposite direction. So the velocity is increasing, but in the opposite direction. This side, the gradient is positive, then this side, the gradient is negative. You see that? The gradient is equivalent to the velocity. As the gradient increases this side, it means velocity is increasing, but in the negative direction. Okay, remember we talked about this. At the same displacement, the gradient here positive, and then we have the gradient there negative. The magnitude of gradients is the same, but they have different directions or different signs. Right, we'll discuss more about the position time graph in our next lesson.